Hello guys, so today we will solve this problem tuple with the same product. So let's see what the problem says. Given a array nums of distinct positive integers, return the minimum number of tuples. Return the number of tuples a b c d such that a into b equals to c into d, where a b c d are elements of nums and a is not equal to b and c is not equal to d. Okay, so basically we need to find this condition, means the tuples which satisfy this condition and also they are not equal. Okay, and elements are positive distinct integer. So basically we in our array have all the distinct elements. So I think we can say that we should not take a element twist. If we are taking the element twist, then our this condition can violate, means this condition will gonna violate. Otherwise we can take any combination of the tuples. Okay, so let's see an example. So here we have 2 3 4 8. Okay, so answer is 8, means here are 8 valid tuples. Okay, so basically ordering here is not mattering. Okay, means the tuple can have any ordering. Okay, so ordering here is means we are taking 2 6 3 4 and we are also taking 4 3 6 2. 4 3 6 2. Okay, so we can take elements in any order. Let's say we have distinct element, and if we find a tuple and we can arrange that tuple, the particular tuple, in 8 ways, means we can arrange a tuple in 8 ways. So what we can say is any pair, means any tuple which satisfies this condition, we will count 8 for that tuple, means instead of 1. Okay, let me think. Suppose we have this particular array. Okay, so if I start from 1, then I can take 2, then with 1 I can also take 4, then with 1 I can also take 5, with 1 I can also take 10. With 2 I can take this, with 4 I can take this, with 5 I can take this. Okay, uh, means let's say for now we print the pairs which we can take. Nums dot length I less than n I plus plus for int I int j equals to I plus 1, j smaller than n, j plus plus system dot out dot println. So we will print a tuple, basically nums of I plus nums of j and at the end we need to return something. Let's for now return 0. Let's run. So we have got all the pairs basically: 1 2 1 4 1 5 1 10 2 4 2 5 2 10. Okay, now we need to match the pairs with the same product. That how many pairs have the same product? Okay, for example, here 10 into 1 is 10, and 2 into 5 is also 10. So we can take the count as 8, because we can arrange it into 8 ways. Okay, similarly we have 10 into 2 20, and 5 into 4 20. So we can arrange it into uh, 8 ways. So total ways we have is 16. Okay, so can we something do like means we can store the frequency of a tuple. Suppose we have these two tuples, and then we encounter a third tuple. uh, let's say we also have a third tuple 1 and 20. Okay, so initially we will have 1 and 20, then we found the 2 and 10, means its multiplication is 20. Then we find another pair having multiplication as 20. Now we can say we have total 8 tuples, means if we combine these two pairs, then we can have 8 tuples, means 8 combinations. Then we reach this particular let's say pair, and we see that this pair's multiplication is 20, and we have already seen the pairs which have multiplication of 20, means we can match this tuple with this tuple. So 8 plus 8 16, and this tuple with this tuple. So 16 plus 24. Okay, basically 8 into these frequencies. Okay, so I think what we can do is we can store the multiplication and its frequency, means we do not need to take care of the duplicates, because we are only transversing a element once. After that we are checking elements after it. So we and all the elements are distinct, so we don't need to keep track of the repeating elements. Means we can store the frequency in a hash map, like let's call this a frequency map. And what we can do is we find the multiplication, means multiplication of a current pair, which will be nums. Let's see values if multiplication can't get out of bound. Okay, so this is 10 raised to the power 4, so multiplication can be at max as 10 raised to the power 8. Okay, so we multiply these two numbers. So basically we are multiplying 1 and 20, which gives us 20. And before multiply what we can do after multiplying, we can check in our hash map if this particular element exists in our map. If it exists, what's its frequency? So let's calculate the frequency of this particular product. So what we can do, we can check in our map.get uh, get the frequency of this multiplication. Otherwise, get or default means if it not present, then we can return the default value of let's say we can return the default value of 0. Okay, let's also initialize our answer variable. So initially we have 0 tuples, at the end we can return our answer. So initially we have so we reach this position. So initially it is not present in our map, so we will return a 0 frequency. And what we can do, our add to our answer 8 into, okay, means one tuple can for example these four numbers can form 8 tuples, means these combinations uh, 8 into the frequency of, means 8 into this frequency. Okay, and then we can put, means then we can increase the frequency of this particular product. Frequency map dot put this product, let's call this product command D. So we will put this product. If this product is already present, then we will just increase its frequency, product plus 1. Means what we are doing, we are putting this product into the map. If it's already present, we will fetch its frequency and add 1 to it. If it's not present, we will fetch its frequency as 0 and add 1 to it. Okay, so we will that way put our answer. So we can dry run it for this particular case. So we put product 2 into 3 6 into our tuple, then we put this 2 and 4 8 product into our frequency map, then we will put 12, then we will put 12 again. So when we are inserting 12, we see that we have already product as 12, so we will increase our count to 8. Okay, then we will put 18, so 18 is not present, then we will put 24. Okay, so that way it will work. So let's see if this works. Okay, so this is a perfect solution. So this was the problem of the day. So okay, thank you guys.